Bristol Community College, Mathematics with Dan Avedikian, Math 119, Fundamental Statistics, Section 6.2, Problem 2. This is Section 6.2, Problem number 2. It says the probability that lazy Larry will be late for work is 37%. Use the binomial probability formula, n combination x times p to the x power times 1 minus p to the n minus x power, to find the probability that in the next 5 days, Larry will be late 3 times. So when I have one of these problems to do, what I like to do is write the formula. And then off to the side next to it, write n equals, x equals, p equals, find the values, and then I can fill in the formula and start the work. So n is the number of trials for the experiment. So for this particular problem, n would be 5, because it says in the next 5 days, Larry will be late 3 times. So 5 for n. X, number of successes. So what we're trying to find is the probability of Larry being late. And because the question mentions 3 times, that's going to be our x, our number of successes. P is the probability of success given as a decimal. So the problem says 37%. So we have to put that in as 0.37. We can't leave it with a percent on it. 0.37 will be P. So now once I know this information, I can go over and fill in the formula. So the n combination x will be 5 combination 3. P to the x power will be 0.37 to the 3rd power. And 1 minus p will be 1 minus 0.37. And the exponent, n minus x, will be 5 minus 3. So that's how the formula fills in. And before I start any serious computation, I'm just going to clean up the right-hand parentheses. So I'm going to leave the first one for the moment as 5 combination 3. I'll leave the middle one as 0.37 to the 3rd power. But the last one, 1 minus 0.37, I can calculate that. That's 0.63. And the exponent, 5 minus 3, I can also do that. That's 2. So now what I have is 3 sets of parentheses. I'm going to need an answer for each set of parentheses. I'll have 3 answers, and then I'm going to multiply those 3 answers together, and that'll be my final answer. So let's start with 5 combination 3. Let me come off to the side, and I will have 5 combination 3. And again, the 5 was from n, the 3 was from x, and the formula for combination is n factorial over x factorial times, in parentheses, n minus x factorial. So now as you fill this in, n factorial is 5 factorial. And then in the denominator, x factorial, x is 3, so 3 factorial. Then in the parentheses, n minus x, so 5 minus 3, close the parentheses, factorial. And then in the parentheses, that'll turn into a 2. So I have a 5 factorial on top, underneath a 3 factorial times from the parentheses 2 factorial, again from the 5 minus 3. So now let me write out the factorials. 5 factorial is 5 times 4 times 3 times 2 times 1. And in the denominator, 3 factorial is 3 times 2 times 1, and 2 factorial is 2 times 1. And you can multiply all of that out and then reduce it, which will work. It'll give you the right answer. Or let's at least do 3, 2, 1 in the bottom, 3, 2, 1 in the top, and cancel that. So on the top, you'll have 20, the bottom 2. 20 over 2 reduces to 10. Or you could even reduce a little bit more. 2 goes into 2 once, 2 goes into 4 twice. 5 times 2. Either way, you get 10. So the first parenthesis has a value of 10. Now the middle parenthesis, 0.37 to the 3rd power, let me write it out. I can come underneath here. 0.37 to the 3rd is 0.37 times 0.37 times 0.37, which the calculator will do very easily for me. That's kind of tough to do without the calculator. And if I enter that in my calculator, the middle parenthesis has a result of 0.050653. And then the last parenthesis, 0.63 to the 2nd power. So 0.63 to the 2nd equals 0.63 times 0.63, which again the calculator will do very easily. Let's see, 0.63 times 0.63. I get 0.3969. So now to finish the problem, I'm going to multiply 10 times 0.050653 times 0.3969, and that'll give me my final answer. And the calculator gives me a final answer of 0.201041757. Now we don't need that many decimals. You can either call it 0.20 or 0.201 if you want 3 decimals. So it's a little bit more than a 20% probability. So again, if you have a job where you're working with this lazy Larry person, the probability that he's going to be late 3 times in the next 5 times he has to go to work is slightly more than a 20% probability.